and a set of services that are accessed. But then there are other much more frequently referenced pieces of data, like contacts or something that might be technically part of the CRM pillar because maybe they developed the functionality behind contacts, but it's used so frequently by the human resources pillar that certain entities and views are marked as being replicated, and so they've built data replication infrastructure that's a custom application of their own, that then a team like HCM would take a library of what they call read-only public VOs and EOs. That's a term they invented themselves. They're just VOs and EOs with no logic in them. They have the same structure as the so-called private VOs that are running inside the CRM pillar. And they really just exist so that the team over here can do joins and easily involve the attributes of the contacts in queries that go against replicated data. So this picture drastically simplifies the actual environment. So it's taken quite a lot of fiddling and experimentation to get to this type of architecture. But the features in the product support doing something like this if you would need to do that type of separation. And you may never have noticed it, but if you ever created an entity object, you might see in the data source section there's a little radio group that says service interface. And normally you create an entity based on a table, and so that's the default setting. But if you choose the service interface, a few extra fields pop up and let you give the WSDL of the service that's going to support that entity. And also there could be multiple view instances that are in that service. And so you pick a couple of pieces of metadata, and then this entity object is like a dedicated little proxy that knows how to call the service to do any CRUD operations or query operations. And then you can easily build a view object on top of this service-based entity object and get data from the remote tier. They also adopt a strategy of kind of creating separate kinds of application modules. So the app module itself doesn't have, there's only one real kind of app module, but they've decided in their use cases that since often they have common logic that needs to live in a central place, they don't want to write it twice, they separate that into their core model project and a core model AM. And then sometimes they have specific needs for a task flow that needs queries that aren't really part of the core validation and lookup. And so they use a UI model project to be what supports a task flow, often using view objects from the base model project or creating a few new view objects as needed. And the UI model project is something that would be packaged together with the task flow for reuse. And then finally, a service is an AM that's exposed as a service interface. Sometimes what you need to expose in your UI is different than the shape you'd like to support for the next 10 years over your public web service interfaces. So sometimes the view objects that they create in the service AM look a little bit more anemic, a little smaller, less data showing to the public service interface. But they all delegate to the model AM, either through nesting that AM or delegating to it in some other way, or by extending it, sorry. And also just a simple aid for knowing what kind of components, looking at a given name of a component so they instantly know what it is. They adopt a simple, what's called a Hungarian notation, where every VO has the two letters VO at the end. Every EO has the EO at the end, AM at the end. And there's some places in JDeveloper where you can teach us how you'd like to name your classes, and then we'll adopt your naming pattern. You may never have visited that page, but you can configure it to use your preferred naming pattern. And so they do that to make it simpler. When they start to build libraries, they mark particular projects as being public, protected, or private. This again is like a custom idea that they have adopted to deal with some of the dependency issues. So things that are in a private library are only used by the team that created them for packaging purposes. Things that are in a protected library are indirectly used by some reusable UI widgets like customer pickers and customer search UI that every app might include. So they're kind of pulled in by a public UI project. And the public project has reusable components that any team can use. Sometimes they're remote, like we just talked about, and work over web services. Other times they're local and being used against replicated data. So that gives you a little bit of a flavor for some of the way that Oracle Apps is structured and some of the additional concepts they've invented to try to deal with some of the large size app problems. Next, we'll look at some view controller best practices. So one of the first things that I try to tell developers when they start using ADF is that they really should think every time they start writing a backing bean, whether that's something that really needs to exist. We have so many features that allow you to accomplish things declaratively, especially features like writing custom methods on an application module or a view object, exposing those to be called by the client view controller layer, and then declaratively invoking them from task flows, that there really is fairly little need for writing backing beans. It pains me to see test cases that come in sometimes that have like backing beans that are working with view objects, changing where clauses, doing a bunch of manipulation of the model layer components, when instead that should all just be encapsulated behind one method, and the view controller just says, go do your setup stuff, and that makes it just so much simpler for testing. When you write a JUnit test, you can say, go call the initialization method, and then you're in the same state that the task flow would be in when it started, and then you can start doing some tests with your view objects all set up correctly. UI components, frequently you can accomplish even quite dynamic user interfaces by using appropriate EL expressions that would maybe enable or disable or hide or show parts of your page based on evaluating some expression whose value might change over time, but the actual text of the expression is something you can do at design time and don't need to write code to enforce. In a task flow, router activities can typically do quite sophisticated conditional routing. If this is true and that's true and this value is this, then go to that page, otherwise go over here. And so the only kind of thing that really ends up needing to be in a backing bean is something that really is complex UI component manipulation, maybe like dynamically creating UI elements on the page that weren't there before, or doing some really sophisticated type of restructuring of the way that the beans are layered so that you couldn't have done that using the EL, or some kind of very complex conditional navigation that can't be done with a router. If you have to put backing bean code in to do one of these two things, make sure that you still invoke, the exposed client methods from the app module or a view object using action bindings. It's like a little bit, the first few times you do it, it kind of seems like it's a little bit of extra trouble, but what you'll find is that by going always through an action binding, even if it's by programmatically causing the action binding to fire, all of the error handling will just work correctly. Whereas if you try to write Java code that calls the methods directly without using the action binding, if an exception is thrown, it'll be in your lap to handle it in the elegant way we normally handle all exceptions. And so I would advise to go the path of using action bindings, which have all the try-catch logic in there to route things to the appropriate error handler. Another very common problem that I see is in a backing bean, people want to access the application module for one way or another, or cause a method to fire. And this is the correct way to do that. Let's say that just declaratively invoking an action called the right way method wasn't enough. You needed to write a little bit of code before or after invoking it. So by getting a hold of the page definition with the get bindings method there, finding the operation binding by name, and calling its execute method, that's the right way to do things. You'll be using the same app module that the rest of the page is using. You won't end up checking out multiple app modules accidentally, and in general, your app will just work correctly. What I see too many times, unfortunately, is because it's kind of a two-edged sword. We created a very simple API for working with an app module called create root app module. And so since it's very simple, people tend to think of it first when they say,